Part A of this problem asks about average velocity, and we do have a formula for average velocity when we're given information about the position. The formula for average velocity is that it's a net change in position divided by a net change in time, or in other words, x2 minus x1 over t2 minus t1, assuming the two variables come after the one variables do. In the context of this problem, the denominator will just contain 2.0 seconds, since that's how much time that this interval takes. For the numerator, we'll have to plug 2.0 seconds into this y formula, and then from that, subtract the same formula, but with 0 substituted in for t instead. Now, of course, basic trigonometry knowledge will tell us that if we plug 0 in for inside of a sine function, the whole term becomes 0, so to save myself some space, I just wrote minus 0 for the second part of this. Either way, though, we put this into our calculator, or we solve this just with pen and paper, and we're going to find an answer of 1.0 centimeters a second. And that is the average speed, so that's the answer for part A. Part B is now asking about instantaneous velocity. The average velocity formula will not cut it for this. We're going to need to have an actual formula for the velocity of the particle. To do this, we'll just take the derivative of the position function given by the problem. So velocity is equal to the derivative of the displacement, or the position function. And so we're going to have to take a derivative of a function that has a sine function in it, which means we'll have to use the power rule. So here's some calculus. So the derivative of a sine function is cosine, and then so we'll have a cosine function, and then we'll multiply the inside of this. So it'll be pi over 4 times 2. So on the outside, that's going to be pi over 2, since the 4 and the 2 will cancel out, since that's 2 over 4, so that's the same thing as 1/2. And that's being multiplied by cosine, the cosine of pi t over 4. Now all we have to do is take this formula that we've just discovered and plug in the values given by the problem. 0 for t, 1.0, and 2.0 seconds, all for t. For t equals 0, we find a speed of pi over 2 centimeters per second. For 1 second, we find a speed of pi times radical 2 over 4 centimeters per second. And for 2 seconds, we just find a speed of 0 centimeters per second. So that's it for part B. For part C, we want average acceleration. So similarly to average velocity, average acceleration is just a change in speed divided by a change in time. So similarly to in part A, it's a change in v over change in t, so it's v2 minus v1 over t2 minus t1. I actually wrote that wrong there, just like this. So once again, we'll have 2 seconds in the denominator, since the motion happens over 2 seconds. And then the interval is from 0 seconds to 2.0 seconds, given right here. So for 2 seconds, we're plugging the 2 in for the t, so the 2 and the 4 cancel out to make a 1/2. So we just write cosine of pi over 2. And then for the next part, a 0 is being plugged in for t, so the whole term becomes 0. So that's why I wrote minus pi over 2 times the cosine of 0. And if we can't solve this down or put it into your calculator or whatever, we find an average acceleration of negative pi over 4 centimeters per second squared. And that's part C. And finally, for part D, we're being asked about the instantaneous acceleration. Once again, we'll have to solve for a derivative, because acceleration is equal to the derivative of velocity with respect to time. The derivative of a cosine function is negative sine, so it's a negative, and then times pi over 2 times the derivative of the inner. So that's going to be pi squared over 8 times the sine of pi t over 4. This is now our formula for instantaneous acceleration. So now it's just a matter of plugging in the values the problem gives us. 0 seconds, 1.0, and 2.0. So for 0 seconds, it's an acceleration of 0. For 1 second, it's an acceleration of negative pi squared times radical 2 over 16 centimeters per second squared. And for 2 seconds, that's negative pi squared over 8 centimeters per second squared. So that is our answer for all four parts of this problem. I hope this video helped you out. If you have any further questions, leave a comment down below and I'll try to help you out. If you have any requests or you'd like to talk further, I have a Discord server linked down below. But for now, hope you all have a lovely day.